Hello, everyone. I am David D. Hilster, president of the CMPS, and this is our annual fund drive. First, I want to thank all of those who have been paying their annual and monthly memberships through our automatic membership system. It is greatly appreciated. Since 1994, this group has been pioneering support for critical thinkers outside of mainstream science, and we continue to do so through our virtual presence, through our Saturday morning live streams, and our website discussions. Since last year, we have cut our expenses down to something reasonable for our current membership. In 2026, we hope to implement the Discourse Discussion Group as our primary discussion software. Our current website system, in my opinion, is not ideal. We hope to change that. To donate, you can go to fund.naturalphilosophy.org and donate whatever amount that works for you. Your contributions are greatly appreciated. Thank you.
Hello, everybody. Welcome to another Saturday session of the John Trappell Natural Philosophy Society. I hope you're all having a good day. If you could just hold on for a moment, I will check to make sure the sound's coming across properly. Okay. Yeah. So the sound seems to be coming across. So today's exciting talk will be about quantum myths, and the myths in relativity have led to myths in quantum theory. So I'll be looking at that. So basically what you've got is a methodological shift that happened in relativity, started by Einstein in the way science is to be done, and that's influenced quantum mechanics. And so quantum mechanics is sort of being infected with myths the same way that relativity is infected by myths. So you need some sort of antidote to it. So before getting onto that, let's point out the exciting things that are going to come. I've got a video I can show you from one of my favorite physicists, who's Sabine Hossenfelder. So hopefully I'm going to show you that as well. And I don't agree with everything she says, but she is fighting the mainstream physics community in her own way. So hopefully I'll be able to show you that video. So if I enlarge my screen a minute so I can see it better. Right, so the description is the process that started creating myths in relativity got extended to making myths in quantum physics. So the first issue is, what do I mean by myth? And maybe I didn't make it very clear the last time I was dealing with the myths. So by a myth, I do not mean when a methodological move is treated as an ontological conclusion. The equations may be correct, but interpretation can go beyond what experiments establish these. So a myth is not a failed experiment, and not a wrong equation, and not a false prediction. A myth is a metaphysical overreach when a methodological choice is treated as an ontological conclusion. So basically what you've got with physics is you've got experiments and you've got mathematics and so forth. And so what does the experiment show? You can is what all physics is about. And I to a large extent, I'm accepting the physics side of mainstream physics. So saying they've done experiments and they've actually managed to fit it to their equations and so forth most of the time, and get their data to fit to it, get the data from the experiment, and that fits to the equations they got. So mostly the physics side of things is okay, but it's on top of the physics they have their mythology. So, and the mythology is metaphysical overreach, which means they're placing interpretations onto the physics. and they're going beyond what really the experiments show. So when they do that, they start creating myths. You've got the physics, and then you've got the myths on top of it. And so it's false claims, basically. You've got the essential core, which is the physics, and then up the myths on top of it. And I've been finding this out when I've been discussing it with artificial intelligence. And so artificial intelligence has been describing it this way when it talks about things like special relativity or quantum physics and so forth. It says that is correct. It says that is correct. The physics side of it is correct. It's just the myths that have been put on top of it, which is false. So that is the difference. And the way I think people think is they think of the physics as the myths, and AI is not wanting to treat the physics as the myths. So, or the myths on top. The AI is saying, well, that's not really the physics. And what the myths are is metaphysical overreach. So the method of doing physics, now prompted by Einstein, in my view, he's the main culprit. What the method he's put onto physics is to ends up creating all this mythology, and there's a vast amount of this mythology. So metaphysics is not the physics. The physics part of mainstream physics is supposed to be correct because the equations are fit into the experiments, but it's the layer up on top beyond the experiments and the mathematics, which is the mythology. And so ontology is the nature of things. So what happens is they go beyond what the experiments actually show. They then have that on top of it, and that is beyond what the nature of physical reality is. They're adding all this mythology on top of it. So maybe I hope we explain that to you, and that's what I'm attacking in this talk. I'm attacking the mythology of mainstream physics, and I'm not attacking the experiments for the sake of the mainstream. Yeah, the experiments are correct. It's what they're saying about the experiments is beyond what the experiments actually show, which is the mythology. And so the mathematics they got to fit to the experiments is correct. So it's slightly different to how many dissidents think of their dissent with the mainstream physics. It's sort of like accepting the physics part is correct, but it's all the mythology that's been added on which is wrong. So the issue is physics versus metaphysics in physics. Just to clarify it, physics is the experiment plus mathematics, and it's also observations as well. So whereas the metaphysics is what we say the mathematics means. So you've done your experiments, you've got some mathematics to agree with those experiments, and then the metaphysics is then the interpretation of what that mathematics means. So an example of that would be you've done an experiment and your clocks run differently, and that can lead to different interpretations. The example would be the clocks are faulty. Or another example would be that time flows differently for each clock. So that's the interpretation you're placing onto this physics experiment of observing clocks running differently. You're doing metaphysics then by trying to interpret what that means when you observe clocks running differently. So next slide. So this sort of thing has messed everything up, and this is from Einstein. He's been replacing ontology, which is the nature of things, with operations. So in his famous paper on special relativity, 1905, Einstein wrote, and it's paraphrasing the German, we must define what we mean by time. Time is what a clock indicates. He then defines simultaneity via light signal synchronization. So you've got a way of synchronizing the clocks, and that's accurate to what he's saying. But what does that mean? Question mark. It meant concepts must be tied to measurable procedures. So you are defining things by what you can measure. So time is what clocks measure. And that's undefined notions like absolute simultaneity are to be avoided. So the method he's bringing in is now called methodological operationalism, where you're going by procedures and you're defining things by your operation of measuring things. And that was, I think, different to before Einstein. Einstein had brought that into physics. It wasn't how physics was being done before him. So, like to say, the first relativity myth, what I'm doing is I'm going to lead on to the myths in quantum physics. And so it starts off with the myths in relativity. And from the myths in relativity, it then leads on to having myths in quantum physics. So the whole of mainstream physics has been corrupted by mythology, basically. So, and this is as per, in my view, started by Einstein. But you probably might be able to look and find it started happening a bit before him, because you had other people like Mach saying things which influenced Einstein's way of thinking. So relativity myth number one, operational definitions eliminate ontology. So it's the nature of things. So Einstein, 1905, time is defined via clocks. So what clocks measure is what time is supposed to be. And simultaneity is defined by a light signal. So you're measuring light going from backwards and forwards, and you're defining time. Simultaneity be defined by that. So you've got clocks, and you're imposing on the clocks that they should be measuring constant light speed, and the consequence of that is you are then changing what is meant by simultaneity. And so the myth from that is only operationally defined entities are real. And this is, to a large extent, the basis of what Einstein has done. He's imposed this myth onto physics, that only operationally defined entities are real. And that, as I said, is not what physics was before him. So relativity myth number two is no preferred frame can exist. So before Einstein, you had the Lorentz theory, and it had the same sort of mathematics as used by Einstein in special relativity, which is called the Lorentz transformations. And in the Lorentz theory, you were using the same maths as Einstein, but you were keeping a preferred frame. But Einstein wanted to jettison that. So you've got two, in that sense, two different theories. One which has a preferred frame and one without a preferred frame. So you've got the split there. So, and what was you've got that split, and both theories are supposed to be empirically equivalent, in the sense that experiments that agree with special relativity also agree with Lorentz theory. So you've got that. So you've got a theory with a preferred frame and a theory without it. My voice is going. And so you've got two theories, both supposed to explain the relevant same experiments. And the myth comes about is, if not mathematically required, it cannot physically exist. So Einstein's special relativity is going with the idea you don't need it. A preferred frame does not exist because you don't need it. And that's a myth. That is, how can you get that? How can you suddenly get that idea that it's not required? It's sort of a myth. It doesn't, there's no reasoning as to how you can do that. So, relativity myth 3, geometry replaces dynamics. And this came about more in the case of Minkowski in 1908 when he introduced space-time geometry. And that sort of got adopted by Einstein and brought it into his special relativity. So the myth that generates there is geometric description eliminates underlying structure. So suddenly you're talking about it in terms of this geometry. And suddenly, well, that's supposed to change everything. How do you do that? It's just a myth. And so the description does not equal explanation. That's the problem with that myth. And then we would lead on to relativity myth number 4. Principal theories make constructive models obsolete. So to a large extent, before Einstein, theories were constructive. And Einstein distinguished between principal theories and constructive theories. So Einstein was building his theory, special relativity, on the principle of relativity, and he wasn't doing it the old way of constructive theories. And so the myth becomes the constructive ontology is unnecessary. So you've had constructive theories before Einstein, but Einstein goes for a principal theory and the myth is created, you don't need constructive theories anymore. And there's no reason for thinking that, so it's just a myth. And there were many other myths brought in, built on top of what Einstein's approach to physics was. His approach to physics is to create myths. When people try to understand what he's talking about, they create this myth, which is not based upon interpretations or not based upon experiment. It goes beyond what the experiment actually shows. So a methodological shift occurs as it's from, this is what Einstein's done, it's a shift from talking about mechanical models with underlying structures and absolute frameworks. And so Einstein changes that to being about formal invariance principles, such as the relativity principle and about the speed of light, so say, being constant. And then it goes on to about operational definitions where time is now suddenly what clocks measure, and it wasn't that before. And then it goes about structural description, which is the case of the space-time geometry. So observer dependence becomes normalized. In relativity, you're talking about what observers measure or see or observe. And so that's the issue that becomes happening now in physics. Physics is now observer dependent. And so relativity has simultaneity and now depends on the frame of the observer. And now we move a bit on to quantum mechanics. Its outcomes depend on measurement context. So the shift from the observer being important in Einstein's relativity gets incorporated now into quantum mechanics with this idea that outcomes depend on measurement context. So, and the measurement is being done by the observer, most cases. That leads on to the idea of the Schrödinger cat paradox, where we have a cat in a box and you don't know whether it's alive until you look in the box. So reality is then depending upon the observer. So it's a carry on from relativity being about the observer, and now it gets incorporated into quantum mechanics. And so that is the psychological move. Description depends on observational structure. And so with Einstein, it's removing absolutes. You're moving absolute space, absolute time, and absolute frames of reference. And one of the things it removes is absolute simultaneity. And so Copenhagen interpretation removed indeterminate pre-measurement properties. And so there's sort of like a connection there with relativity, getting rid of absolutes. The Copenhagen interpretation of quantum mechanics is trying to do the same thing. So the quantum myths become observer creates reality, and that's in the case of the Schrödinger cat's in the box, and it depends upon the observer as to what reality is, because you don't know what the reality is until you look inside the box. The observer creates reality, so say in that mythology. The next issue becomes particles exist nowhere until measured. So reality does not exist until the observer measures it. And what is called the wave function, that collapses when an observation is made. That function is collapses. So, and it's kind of magic. Well, how can the observer collapses a bit of mathematics before the observation? The wave function just continues continuously, and everything's blurred into probabilities. And then when an observation is made, suddenly it collapses into one possible outcome, and that's sort of like magic. How does that work? There's no sort of mechanism for that. It's sort of like, how does the observer do that? Next slide. So what is the deeper pattern is a shift from the constructive ontology, which is the nature of things. So you had that before Einstein. You had constructive theories being built before Einstein. Suddenly that was the nature of things, and then it got shifted to a formal predictive structure under Einstein. And so the myth appears when formal success is treated as ontological finality. So that's where the myths is coming from. So it's an important clarification. So Einstein himself was opposed to quantum mechanics. He had a famous discussion with Niels Bohr, who was one of the founders of quantum mechanics, along with the others like Heisenberg and so forth. And he was opposing the construction of quantum mechanics, and he opposed their interpretation. But the methodology which led to building quantum mechanics was based upon how Einstein was doing physics. So the argument is not that Einstein caused the Copenhagen interpretation. The argument is his methodological shift, which he did for relativity, made later interpretive moves, such as the Copenhagen interpretation, that much easier. They were just following his way of doing things. So the core thesis is the 20th century physics increasingly emphasized predictive accuracy over metaphysical intelligibility. So what happens is before Einstein, you would have you would have to have a good understanding of metaphysics as well as physics. But with Einstein, it's sort of like it was sort of like abandon making the metaphysics make sense. So you were getting rid of metaphysical intelligibility with his introduction. So it's when an interpretation outruns experiments, myths arise. So we have the quantum physics extended the trend from what Einstein did with this methodological approach to physics. So in relativity, you have the idea there's no ether. That's the usual way that it's presented by the mainstream. And some people sort of like believe in relativity, but think, oh, there should be an ether. But the usual mainstream point of view is that there's no ether. And that move got extended to quantum physics and became part of the no classical trajectory. So in classical physics, you would have a definite particle and it would have a definite trajectory. But now in quantum physics, it's all airy-fairy, and without an observation, the quantum entity hasn't got a definite trajectory until it's observed. And the next thing with the relativity move is about the operational time. That's where time is what clock measurement, clock is time is what clocks measure, instead of time being independent of the measuring instrument. And that got moved over into quantum physics with the idea of operational measurement. So in quantum physics, you've got the idea that you've got to make a measurement for it to become reality, and the measurement depends upon the observer. And so in relativity, you also had the geometry was replacing mechanism, and that came about because of the Minkowski space-time being brought into it. Everything was tied into that. And so as a similar sort of thing in quantum physics, where you have this thing called Hilbert space over mechanism, you're replacing mechanism by its own type of geometry. Hilbert space is where you're dealing with probabilities, and that's in a sort of geometry. And so the relativity moves also towards principal theory, and that caused what happened in quantum physics, where it became about the axioms of quantum postulates. You suddenly brought in more. You brought in quantum physics, and it was based upon these postulates about uncertainty and all of these other things. And so it became a theory of principle as well. So the conclusions are that Einstein's way of thinking about physics, by going in a different way to what was around before him, which was then existing, had an influence on the development of quantum physics / mechanics. So, and that was despite Einstein being opposed to quantum mechanics. He didn't like the direction it was going in, because it was using his same sort of method, but he was going at it in a different way to his method that he was building relativity on. So quantum mechanics was still based on his type of thinking. So trying to go against relativity, and you're really going against the whole structure of how physics is now being done. So the whole method of physics is now opposed to going against relativity. You go against relativity and you oppose the method that's being used there, and it's the whole ingrained thing into how physics is to be done by the way that Einstein was doing it. Physics is not being taught properly. It's not going into the relevant details of the changes that Einstein made to doing physics. So it's not telling the physics students that before Einstein, physics was done in a different way. That they're just getting straight into there and giving you a method of how physics is being done, and not pointing out to you that is a different method to what was originally being done. And it's probably because that is too complicated to discuss at an easy student level. And so what happens is, instead of proper physics, the myths are being taught. All the myths are being taught to the physics students, and that's supposed to be to help them to understand the subject. So I do have a video, and it's this video. If I can sort of like bring it up. So I remove from stage. I'll bring this video up now. So hold on. Hi. Hold on a minute. So I'll do my best to try to bring this video up. Two comments so far. So okay, nothing important coming up in the comments, I don't think. So bear with me when we get to it. Bear with me, I get to it. So hold on. It's got a share screen. Quantum myths. Share. Delete. Pause. Wait. So if I could, let's stay. So unfortunately got the advert on the moment. So this is one of Sabine Hoffelder's videos, and she's a physicist, definitely, and she's gone against the mainstream, but she doesn't really follow many of the distant physicist point of view, but she has noticed that there is a lot of myths in quantum physics, so that's why I found it interesting. But sort of like the myths, I asked AI what are the myths, and it's come up with about 100 for relativity and about 100 for quantum physics. So Sabine is only talking about just a few of the myths. She's talking about 10 of them, when actually there's numerous myths. Sort of the whole of modern physics is really based upon telling people these myths. And when you got a science popularizer who comes on, like Neil deGrasse Tyson, or in UK the person is Brian Cox, and that they're just talking myths. That is what these popularizers do. They just talk myths to the public, and the myths are very interesting. They're sort of very exciting things to talk about, these myths, and so that's their popular science, popular physics to the students, to the viewers, to talk myths. And unfortunately, when you're maybe you watch that and you get, well, that's interesting, and you then go on to a physics course, and unfortunately that's what they teach you. They just teach you myths, basically. So that's the whole corruption of physics at the moment, and people are only just becoming aware of it. And as I said, the AI has pointed this out to me, that most of what people believe is physics is really just mythology. So I tried to play the video. I'll bring myself down.
Pop. Learn the latest trends, stay updated, videos change fast. Plan your content, be consistent and creative. Know your platforms, adapt content. Each one's different. Edit like a pro, cut, trim, and generated content, or just find your next creator on
I recently made a video about 10 physics myths, and a lot of you asked that I do another one about quantum myths in particular. So here we go, starting with 10. Quantum physics means discreteness. Electrons sit in shells around atomic nuclei with gaps between them. The energies of those electrons are discrete. They come in steps. There are other cases where quantum effects lead to discreteness. For example, the photoelectric effect, which demonstrates that light is made of packets of energy, quanta, called photons. However, quantum effects don't make everything discrete. The position of an electron that isn't bound to a nucleus, but is, for example, moving through a wire, is continuous. And while you can interpret light as made up of those quanta, the photons, they can take on any energy. So basically, some things become discrete, others don't. 9. Quantum physics proves that parallel universes exist. I personally blame David Deutsch for this confusion. You see, David Deutsch has used a particular interpretation for how a quantum computer works, according to which a quantum computer gets its special power by parallel computing in multiple universes.
It's almost a century since the theory was proposed, and half that time it has been known that it describes a multiverse. And yet that proposition is still disputed by most physicists.
And it's not like this is wrong. It's just that it's a physically meaningless statement. You can as well interpret the maths as taking place in just this one universe. Then there is the many worlds interpretation of quantum physics, which is actually about something different, namely that a measurement doesn't collapse the wave function. Possible outcome happens in a separate universe. Again, this is just a weird interpretation of maths. Operationally, the many worlds interpretation works exactly the same way as the more standard interpretation with the collapse. That parallel universes exist is what I call an ascientific idea. It's not wrong, but it's not supported by any evidence either. 8. Quantum physics means that nature is fundamentally random. The mathematics of quantum physics has a random element that's entirely unpredictable. Does this mean that nature itself is fundamentally unpredictable? We'll never know. It's a question that's impossible to answer by scientific test. You can never rule out that there's a way to calculate what seems unpredictable. So you should be wary of people who say otherwise. They make an impossible claim, which isn't good. 7. Einstein was wrong about quantum physics. I don't know why people keep claiming that Einstein used the phrase spooky action at a distance to refer to entanglement. I read the letter in which the phrase appeared. It's not about entanglement. Einstein was almost certainly referring to the collapse of the wave function, which he had earlier referred to as a peculiar action at a distance. Entangled particles are correlated. There is no action between them. If you do anything to one of a pair of entangled particles, that will not do anything to the other particle. It doesn't even make sense to refer to it as an action, spooky or not. Entanglement has been proved to be real. If you mistakenly think that Einstein referred to entanglement, you'd conclude that Einstein was wrong. But it's not what he meant. There is no evidence that the collapse of the wave function, that is Einstein's spooky action, is actually real. So no, Einstein was not proved wrong on this. That said, Einstein was wrong about some things he said along the line about quantum physics. But on this particular point, the jury is still out, maybe in more than one place at once. 6. Quantum entanglement is faster than light. This misunderstanding is closely related to the previous one. If you know that entanglement has been proved to be real, and you mistakenly think that entanglement is a spooky action at a distance, then you erroneously come to believe that you can use entangled particles to instantaneously affect another particle elsewhere. Because, hey, it's an action, right? But no, it isn't. Quantum physics does not allow you to send information faster than light. There's literally a theorem which proves it. There is no action in entanglement. It's a correlation. 5, we can't quantize gravity. This isn't so much a myth as a misunderstanding. We can quantize gravity. It's been done already in the 1960s. It's just that this theory breaks down at super high energies. This isn't per se a problem because it might just mean that the theory is incomplete, like Einstein argued that quantum physics is incomplete. However, if you think that the next theory in physics will be a final theory, one that completely describes everything, then it's a problem that quantum gravity breaks down at high energies. It's this belief that we're close to a final theory of everything that's led to a lot of failed approach to quantized gravity, like loops and strings and causal dynamical triangulations and so on. 4, superpositions are strange. Saying that a quantum state is in a superposition doesn't mean anything. A superposition is a sum. That's it. And unless I tell you a sum of what it is, anything can be a superposition. I am a superposition. I'm half a Sabine plus half a Sabine. More seriously, you can think of a wave function as a vector of length 1 pointing some direction. That's the direction in an infinite dimensional Hilbert space over the complex numbers, but let's leave aside the subtleties. It's a vector. You can always write this vector as a sum of 2 other vectors. So any wave function is a superposition of something. What physicists often mean when they talk about a superposition is a superposition of 2 places, a sum of a particle in one place plus another. This just isn't anything that we encounter in daily life, so we have no good words to describe it. This is why we often say the particle is in 2 places at once. But this is really just words for a mathematical property that defies explanation. So superpositions per se are not strange. What's strange is superpositions that have no interpretation in our classical world. This leads me directly to what's the most technical point on my list. 3, superpositions are the same as entanglement. An entangled state is one in which at least 2 systems share some property. So the 2 systems are correlated because every state is a superposition of something. It does make sense to say this state is entangled. The short summary is, if you want to sound smart, talk about entangled states, not superpositions. If you want to sound really smart, ask about the Schmidt decomposition and then excuse yourself to the bathroom. 2, quantum physics is a theory for the microscopic range. Quantum physics is a theory that applies to everything. It's just that in most cases you can't. However, quantum entanglement, meters apart, are Bose-Einstein condensates in which particles take on one common quantum state that can contain millions of atoms. There are even theories in which dark matter has quantum properties that literally stretch throughout entire galaxies. Loosely speaking, the bigger and the warmer an object is, the more difficult it is to observe quantum properties. But strictly speaking, the quantum properties never go away. And this brings me to 1, consciousness influences the outcome of quantum processes. In the early days of quantum mechanics, physicists struggled a lot with the notion of a measurement that appears in the mathematics of the theory. This is because the maths leaves it unclear just exactly what a measurement is. One of the ideas they had was that a measurement has something to do with the person who made the measurement. This is how quantum mechanics became linked to consciousness. The idea was pursued for a while, for example, by John Wheeler. However, I don't know anyone who still believes that consciousness has anything to do with the outcomes of measurements. While we still have no good definition for what a measurement is, that's the measurement problem, physicists today mostly agree that it just requires a device that amplifies the quantum behavior to macroscopic scales. Yes, there is some controversy around what exactly macroscopic means, but one doesn't need a conscious being for a measurement.
I think we're going to.
Sounds off. I think I managed to stop it in time before it goes into another advert. So if I try to remove that now, if you're interested, you can go and watch watch the video again. But one of the thing is interesting is what she's saying is the quantum physics myth number one is about the observer. And that is what comes from Einstein's relativity. In Einstein's relativity, the observer is important because observing from a frame of reference and an observer in another frame of reference is getting something different. So reality is depending upon the observer from whatever frame of reference they're in. And so that from that relativity of that, it then gets extended further in quantum physics, where you got the myth of the observer creating reality. So this has all been a myth making process. And if you sort of like, well, let's cut away all the myths and go back to what the experiments actually show. And that's something completely different. The experiments don't actually show, that the observer is influencing reality. The experiment doesn't show that. And then the myth process goes on. Well, there must be many worlds out there, alternative universes, by that many worlds interpretation. So it's all just a myth building process. You're not going by exactly what experiments show, you're just putting myths on top of it and keep on building. So if there's no questions, I can go on to another part of this talk. If I can try to remove this video, which is in the way. Yeah, great. Has anybody put their hand up? No, it's got people in the green room. I think they might be asleep, so, which is good enough, really. You learn when you're sleeping. What you can do if you're doing it right. So, I don't see any hands in the green room. I will now look on to the comments. And they're all looking glazed over. No hands up. Right, they've had their chance. So let's have a look at the comments. So first of all, I think I had a comment in the private chat. Unfortunately, I don't know how to display the private chat. And James Keane points out myth is a widely held but false belief or idea. And that's precisely what it is. Mainstream physics has all of these myths, and they're just false beliefs. And they keep propagating it to the general public and to the physics students, because it's all very interesting, these myths. You talk about twin paradox, you talk about black holes, wormholes, many worlds, reality being created by the observer. It's all very interesting, this mythology. But when you get to the actual experiments, what do the actual experiments show? No, they don't show any of that. It's just myths built on top. Also, the problem with the word myth, it didn't always mean a false belief. It's one of the words that's changed its meaning. And I think Einstein, in his early days, was going by this belief called positivism. And part of the influence of positivism was to change the meaning of myth. So having the belief that myth means a false belief comes from the influence of positivism. And before positivism, that's not necessarily what the word myth meant. But in the modern context of now, a myth means a false belief. So that's basically what physics has adopted. It's adopted lots of false beliefs. Right then, let's go to that's the other chat. So let's go green room. Hi, Roger. Yeah. Hi, Roger. This one says, hi, Roger. Hi, Ian. Hi to you. So, Mr. Dimensional, Mrs. Dimensional Space. Hi. Good morning, and good morning to you as well. Hope you're having a good time. Yeah, I don't know. Yeah, so don't know, says, I think somebody should do a review on Planck's radiation law on this channel. That's where quantum mechanics sprang forth from. Yeah, and part of it comes from Einstein. He was writing about the photoelectric effect. So I just tie it into Einstein. It's Einstein's influence on physics. It's like it runs parallel. Yeah. So I think, I don't know. I think this is referring to Sabine's video. He's saying she's just staying in the office. Don't know who she's talking to. School kids. No, but she does podcasts. It's supposed to be to the general public who's interested in physics, and she's complaining about the mainstream. She wished. Sabine used to be part of the mainstream, and then decided it was a waste of time or something like that, and became a dissident, but not the type of dissident that we're used to in the John Chappell Natural Philosophy Society. So she's rebelling against some things in the mainstream. I think she still has a strong belief in Einstein's relativity. So she hasn't connected the dots back to this mess being made in physics. Goes all the way back to Einstein's influence. I think that's you got some lag. I think that might be referring to Sabina's video. Hopefully the lag is gone now. So you got this. I don't really know who these things are being referred to. So Serena says the entanglement must be almost instantaneous at all levels. It's all mythology, really. That's the dumbest one. Okay. Next. What if light speed does multiplicate as matter multiplicates? I don't pass. I'm not sure what they're supposed to do with things like that. By the famous equation, E equals mc squared, somehow energy is related to mass, which is matter. So this is referring to the video, leave the multiverse out of science and keep it in the comics where it belongs. And I think they're doing a lot of films about it now. In the Avengers, I think the superheroes are jumping around between different universes now. So Kev says, if scientists are just being taught myths, how do they go on and make breakthroughs that change all our lives? Well, the issue is the physics, especially. By going with the AI, artificial intelligence, it's the physics is correct, which is supposed to be the experiments and the mathematics that they use for those experiments. But on top of the physics, they build the mythology. So that's a big structure built on top of the physics. So if you're doing an experiment, you are still doing that properly. It's just how you're interpreting what that experiment means. And that's then leading on to the myths. So the way they want to interpret an experiment is via myths. And those myths are what they teach. And what they science popularizers, such as Neil deGrasse Tyson, would tell a general audiences. And it makes the whole subject very exciting to talk about all these myths about twin paradox, time travel, go fast and speed of light, go back in time, or warp drive and Star Trek. It's all very exciting fantasy, the mythology is. But when you get down to the nuts and bolts of actually doing the experiments, you sort of like just try doing an experiment, getting some data, and trying to fit it into some equations. So Shockwave says, before 1850, myth meant history, not falsehood. Yeah, I think that's what I looked at. It's the philosophy of positivism which came along around about that time, and they want the positivists, those philosophers, wanted to think of myth as falsehood, and so that's become the dominant view. So before that, I think myths didn't mean falsehood, but sort of like words changed their meaning, and positivism became influential in changing the meaning of that word. And positivism also was influential with Einstein in the early days. And so it's all coming from this philosophical and methodological change in physics stroke science, which came about because of relativity and such. So I think so. This one's saying, Serena says, Sabrina's okay. And another comment on it is, she's a grifter. And a grifter, I think, is a con artist. Okay. So then you got a split in point of view about what people think about Sabine. Like, that's so comment to Kev from Green Sciences is, I think you're conflating industry with science. Yeah, so there's several layers to science. You've got the actual doing the science, and you've got the teaching of it, and you've got the theorizing, all these different things. And so Kev says, no, I'm not. Engineering lag science. Yeah. Maybe some exceptions that prove the rule. So in John Chapin Natural Philosophy, we had our top man on GPS, who was Ron Hatch, who sadly now passed away. He was our expert on it. He was a GPS engineer, and he was saying that GPS doesn't work by relativity. And the mainstream said, oh, no. GPS works by relativity. So we had a dissident who was disagreeing with them, and he was an expert on the subject. But I think what happens is it's this split between the physics and the mythology built upon that physics, which is the difference, because I think he was, like most of us, believing the mythology. So when he was saying that relativity doesn't obey GPS, he was thinking of relativity as this big layer of mythology. It's when you get down to the actual physics of doing experiments and getting the data from those experiments to fit equations. That's the actual physics, not the mythology on top of it. Upon that level, the physics of relativity is correct. It's just that everybody's view of relativity now is the mythology that has been built on it, and all that mythology is false. It's just made up stuff to make the subject more exciting. So what's he got here? So they're teaching physics, not myth. No, they're teaching a little bit of physics, but then they're adding all this mythology on top of it. And so don't think Sabrine as a grifter. So yeah, she's an interesting character. I like her videos, but I don't always agree with them. So because I think she believes in Einstein's relativity, and so split on that. And so engineers do whatever is practical, and that what works. Yeah, that's basically what engineers do. So when they set up the GPS system, they're not worrying about the theory of physics behind all that. They're just doing whatever it takes to make the thing work. And it's when the theorists come along later, and when the theorists come on later and look at the GPS working, then they add all their mythology on top of it. So that's it. and can it be practical if it doesn't work? So yeah, that's the important thing. Despite all the mythology that is being talked about in physics, you've still got to get down to the engineering issue and make the things work. Yeah. Yeah, Tesla, the best engineer ever. Yeah, he was very interesting. And we got the correction, the typo error there. Next one. Yeah, if it doesn't work, nobody will buy their products. Yeah. Yeah, so they got to make something work. Yeah. So who's this? Shotwave says, cosmology lags behind the electric engineers. If the universe truly is electric, then they can tell us how and why. Oh, I think he's talking about the electric universe theory. So I'm talking about mainstream physics. My attack normally is upon mainstream physics, what they got wrong. So, who's this? Kev says, I looked into Hatch's claims and patents, etc. Not a good authority you think he was. You are. And now myth making. Not really. I'm just saying that Ron Hatch, I think, was mistaken about the physics of relativity, and I'm making the difference between the physics of what is getting the experiments to work, and that's supposed to be the physics side of it, and the mythology is the stuff added on top of it. So I think, like a lot of this, he was fooled by the mythology as to thinking what relativity was. So I agree she is an interesting character, but I think it's Sabine, yeah. So Eric says, I point out different myths. The myths of particles causing fields. The other myth is that energy conservation requires particles. My experiments show how quantization fails. So I pass. I'm more attacking upon what mainstream says. Particles do produce fields, so I don't know. A difference of opinion there, I think. So, Kev says, engineers don't invent GPS. They were all scientists. You can look them up. Only 4 or 5 of them. So I don't see what's that supposed to mean, because engineers were the ones that trying to make it work. So engineers are more on the practical side of things. So Serene says, all fades of time, so many make longer energy conservation, but never eternal. Pass. Don't know. So, any hands in the green room? I think I'm up to date now on the comments. Oh, yes. Dennis. Dennis is awake. So.
Hello.
Hi, Dennis.
Hi.
Okay.
I just wanted to make the point that you pointed out in one of your earlier lectures that one of the flaws of relativity was that the GPS system, when it sends out a signal to a satellite, it takes into account the rotation of the Earth. Remember that? Remember saying that?
Yeah, when you go and buy a special relativity, as per what Einstein wrote in 1905, it seems to be, when you put aside all the mess that's coming out of it, you're only dealing with straight line motion, which is inertial motion. And when you deal with rotation of the Earth, you've got to deal with non-inertial motion. So it is a bit of a bodge then. You've got to do an add-on to the original special relativity.
Well, it's, he wrote a book, Ron Hatch, Escape from Einstein.
Mm-hmm. Yeah.
And he points out that it's just not just an add-on. It's a fact, because if the Earth is rotating, instantaneously a person on the Earth is moving in a certain direction, as long as he stays on the surface of the Earth. And so it's not just an add-on. Special relativity is wrong because in order to get the accuracy, the 1 centimeter accuracy of GPS that was gotten by Ron Hatch when using his Hatch filter and some other inventions. This accuracy insists that, as a theory, that the as I said, you've got to take into account the rotation of the Earth, because anyone on the surface of the Earth is moving with a velocity of the radius at that point times the rotational angular velocity. It's not just an add-on, it's a basic theoretical flaw. Ron has a paper, a 2007 paper, A New Theory of Gravity, and then it goes on, it's quite a long title. And he points out that the new theory rules out general relativity, Einstein's gravity theory, and it also rules out special relativity as being wrong. And, this paper is published by the journal Physics Essays, and it's in 2007. You can look it up. It's not a real hard read. It doesn't have all kinds of tensors and everything. It makes it a difficult read. But Ron believed in simplicity over complexity, even though what he did was very complex. And Sabina has a book, a very interesting book called Lost in Math. Yeah. And in it, she interviews various very well-known physicists, and then records the interview and then writes about it in her book. And basically, it shows that these physicists are not interested so much in experiment as in their idea of supersymmetry, which it can never, no accelerator has ever produced any evidence that it exists, but they don't give up. They just build another accelerator that's even bigger. And that doesn't make the supersymmetry appear either. But they have no cutoff point where they say, well, we've tried hard enough, and so now we're going to try some other idea, because their books and papers are on supersymmetry, and where would that leave them if they did that? And there seems to be plenty of money from the government to finance even bigger accelerators. Although, I mean, they must be getting near the point where they can't do that anymore, but they will never admit it. So I highly recommend Sabina's book, Lost in Math.
Yeah.
And I think you'll enjoy it. It's not a hard read.
Yeah, I have a point out, I think she believes in Einstein's relativity, though. So she hasn't really sorted out the problems there. When you refer to the physicists working on supersymmetry, it's the theorists and more into that. They're trying to work out a theory.
But they won't give up. I mean, because the money keeps flowing. The Congress does not have what it takes to cut these people off financially.
Yeah. Okay, yeah. So no, I think with the theorists, they've got this bias thing that experiments have shown that certain parts of the mathematics is correct, and so they're trying to build upon that with their theories. So they're already locked into built into the methodology process of Einstein. So, okay, thank you.
Thank you.
Thank you. Cheers. So, okay, anybody else put hands up? So I can move it on. Right then, so let's see back to the comments. I think a few more come in there. Fields fields of matter territory as colors coming from matter as hot said. So back to this maverick astronomer. He's going against standard cosmology. Matter becomes electric, and electric becomes matter. Just doing cycles, okay. Theorizing, speculating. Next, there's a question to you, just to pad on here. Dennis, are you into low energy nuclear reactions? I thought I heard you talk at one of Bob G's videos in a group chat. So I think maybe he is. Next one. Serena says, still matter and fields always come as one to me. So the soul and mind. Don't know. Kev says that's not true, Dennis. Accuracy comes from using differential GPS. Uses GPS as raw input, nothing to do with how the GPS itself works. Don't know what's that referring to. Next. Don't they use Lorentz for sat control? Yeah, so they use Lorentz and a lot of other add-ons and stuff. Lorentz transformations, that is. And so Serena says some get lost in math, but some do see the way. Kev says it takes one position at a known location, GPS presumably, works out the error and transmit error correction to moving receiver. No, I think that's the end of the comments. Yeah, up to date on those. So, Dennis is putting his hand up again. Hi, Dennis.
Hi. The Ron Hatch told me over the phone that the special relativity and general relativity are both incorrect, and it's based upon his work. And I should mention that he was not your typical scientist nowadays who is either an agnostic or an atheist. He was a very devout Baptist. And when his wife became demented, he sold his GPS business so he could stay home and keep her at home and take care of her. And he told me he could only really have time to work 1 hour a day on his physics because all the rest of the time he was taking care of his wife, who was becoming more and more demented. I recommended a natural supplement that would help her, and he said that did help quite a bit, but she was still slowly becoming more and more demented. So he was an honest man. He didn't just talk a good game, he played a good game. And he told me that special and general relativity, according to hard GPS data, were both incorrect.
Yeah. But this is, as I've tried to point out, about the mythology side of things.
No,
Okay.
it's not the mythology. It's not the mythology.
What?
They give the wrong answers, and that's why I mentioned earlier that when the GPS sends out a signal, it takes into account the rotation of the Earth, which is not according to special relativity, because all observer frames are equally useful.
Well, I think that's supposed to be just for inertial. Special relativity is just for inertial motion. When you're going non-inertial, you're supposed to bring in general relativity.
That's wrong too.
Well, that's it. And it just keeps going on like that.
Well, I mean, just read the paper. All you got to do is read his paper.
Yeah.
A new theory of physics. You know, I'm slipping, having a senior moment here.
Yeah. Sorry.
This paper I was talking about before, a new theory of gravity, etc., etc. It's not a hard read, and it shows clearly that both special and general relativity are incorrect, based on hard GPS data. And this is not the mythology. This is the basic calculation. You get the wrong mathematical answer.
I don't think so, because when they have problems with relativity, they do add extra things onto it. I say there's another effect involved.
In practice, they do, but that's not. They're taking liberties when they do that.
Well, that's the way they do things.
Yeah, but they won't admit they're wrong. They just because they have the ability to come up with a fairly good answer. You see, Ron's GPS work made it accurate to 1 centimeter or something like that. Before he came along, the GPS people had a large error, and so if you were driving your car and had a GPS system, and you had 2 right turns, one right after the other, and you had to take one or the other, you wouldn't know which one to take because it was not accurate enough. You have to just try one and then try the other. But when Ron got through with it, it was like 1 centimeter accuracy. And this extra accuracy showed clearly that Einstein's general relativity and special relativity were wrong.
Yeah, they just do add-ons.
Not just the myths, but the actual numbers were wrong.
Well, they just do add-ons when they need to correct things, and they make a claim that the maths, the Lorentz transformations, does fit to certain experiments, and then they admit to having to do add-ons after that for other experiments. So it's all a process of adding things on. Thank you. Is that you got to answer the phone?
Oh, can you hear the phone?
Yeah, I think it's your phone.
Yeah, it is. No, it's in the other room, and I don't think I'm going to answer it.
Oh, okay.
I get so many calls from spammers, you know.
Oh.
Hello, please leave a message after the tone.
Okay. Thank you. Cheers. Is that it? Is it finished? Thank you.
Okay. Yeah. Thanks.
Thank you. Bye. Bye. Cheers. Bye. Okay. Thank you. So there we go. Go back to a few more comments that suddenly coming through. Oh, we've got another hand. Hello, Harry.
Well, good morning, Roger. I like this presentation a lot.
Good. Did you?
Thank you. But I do have an issue with the use of the word myth, and I think that's kind of a controversial issue, as people have different ideas about the word myth means.
Yeah.
And
yes.
I would have preferred to use the word false claim or false belief rather than myth.
Well, I tried to define that I was using it in the way of being a false claim.
Well, myth can mean, a myth is just a story that could or could not be true.
Well, that is a
story.
That is the
could be a fictional story, or it could be a factual story.
Yeah.
And people don't, since people can't really determine whether the story is true or false, it's a myth.
Sorry, in the sense that I've tried to use it is the myth. You don't really have the proof that they're interpreting the experiments correctly. So it's a myth in the sense of if it's true that it's beyond what the experiments are showing.
Okay, can you go back to the beginning to your presentation and put your presentation back up?
You're going to dissect it. Oh God.
Yes, I'd like to do that a little bit because I think you make one really important point, and and people are gonna dissect everything and argue about whether Ron Hatch was right or okay. So move down to the point where you talk about Einstein and kind of move down a bit. I think the real issue is this idea that the observer defines the physical reality. That's really the problem.
Oh yeah,
okay.
Myth.
Okay.
Myth. How far along? Myth 1, 2.
Yeah. So in Einstein's theory, it becomes that the observer defines what is physically real.
Yeah.
And you make that point in there somewhere, and I forget which slide that I wanted you to bring that slide back. And they adopted that in quantum mechanics, where the observer, the physics isn't real. The physical outcome isn't real until it's measured by some observer.
So
okay. And what that means is that reality or the physics or the physical reality doesn't become real until it's observed by an observer.
Yeah.
And that's an idea that's borrowed from relativity.
Yeah.
Okay. But that statement in quantum mechanics then leads to the Schrodinger cat issue.
Yeah.
Okay. And then they've tried to solve that problem with different interpretations. One of them is the parallel universe and the and the many worlds interpretation. That's an attempt to resolve this problem that got introduced, I think, by Einstein with the operational definition. Okay, so this business of defining physics operationally then leads you to the problem that you have to include the observer in quantum mechanics. You have to include the observer and in the mathematical in your theory, so the observer becomes part of your theory.
Yeah.
And when they do that, they get into this issue of the Schrodinger cat. Okay, and that's really an example that Schrodinger put forward as an example of why he thought that the Copenhagen interpretation was incorrect. And then that kind of became a myth. Okay, and that's an example of a story. So the Schrodinger cat is, in my opinion, an example of a myth in that it's a story. Okay, it's a story, and they retell the story. It's not really science. It's not really physics. It's a story. Okay, so that would be a myth. Okay, do you understand what I'm trying to say about that?
Yeah, it's just whether they do try to interpret what the Schrodinger cat thought experiment means.
It's a story. It's a story. It's not physics. It's a story.
Yeah.
It's not physics. It's not about an experiment. It's just a story that he came up with to make a point.
Mm-hmm.
All right. He created a story to make a point.
Yeah.
It was an example that he was pointing out. It's not really physics. It's a story. And so as a story, it kind of becomes a myth.
Yeah.
Okay.
But it leads on to other myths.
Right. But some of the myths that Sabina called myths, I don't think are really myths. They're like mistakes in interpretation or errors in physics. But the Schrodinger one, I would say, is actually a myth because it's a story.
Mm-hmm.
The cat, is the cat alive or dead? It's really a story. It's not really a physics. So this business of calling these things myths can be misleading, I think, to people, and that's really the point I want to make.
Well,
And perhaps
you could dissect it into different types of myths.
Well, yeah, I don't know. The business about the parallel universe thing, that's not really a myth. You could call that might be an example. The parallel universe idea, which what's his name? Can't remember the guy's. David Deutsch.
Yeah.
He promotes this. There's a lot of videos where he's promoting this on YouTube, and it kind of sounds silly, but when you really try to understand what he's talking about, it doesn't really sound so silly and as much of a myth. So if it can be presented as a myth and made to sound silly, but from his point of view, he thinks it's real physics. So it's not so much of a myth from his point of view. So that's kind of an example of it. It could be wrong physics, okay, but I would prefer to call it wrong physics rather than to call it a myth. So this is kind of an area where it's all about what you think the words mean as far as what you mean by a myth.
The words change their meaning over the years anyway.
That's not really what I'm saying. I think some of the examples that Sabrina points out aren't really myths. They're just mistakes. You see what I'm saying?
Yeah, but a lot of people sort of like believe in things that are wrong, and that makes it a myth.
Well, if it becomes a belief that's not really supported by facts.
Yeah. Well, the people, but in the scientific myths, people were believing certain things which are actually wrong, but they believe that's what science shows. So you've got scientific.
Yeah. Now, in the example of entanglement, to talk about in what people believe as myths is kind of, it's like they have wrong beliefs. It's not really a myth. It's just a wrong belief. Do you see what I'm saying?
I was taking myth to be a wrong belief.
Well, to me, a myth is a story.
Yeah.
Okay, that is supposed to explain something. So it's a story. But in the case of entanglement, it's just like, well, you don't understand entanglement, so what you think is wrong. It's not really a myth so much as just being wrong.
I'm taking it that if you believe something that's wrong, and then that is sort of like a myth. Then
no, that's a false belief.
Yeah, false belief is believing in myths.
Okay, so I would rather if she'd said, in her video, these are false beliefs. And to me, it's kind of misleading to say these are myths of quantum mechanics. That seems sort of soft in my mind. It would have been better if she'd have been harder and said, here's 10 false beliefs associated with quantum mechanics. That would have been more hard hitting in my view. Anyway, that's my comment.
I think the myths from her point of view for her video. Okay.
Well, I'm just saying, be harder hitting. Don't call them myths because myths are kind of squishy and soft.
Well, I don't think
false ideas, false concepts, false beliefs. That's really what she was talking about. False concepts, false ideas, false beliefs.
Yeah.
Not myths. Myths are stories. Okay.
Yeah, I think that's the old way of looking at it, because I was pointing out that positivism has changed the meaning of the word myth to being false beliefs. Because I think one of the people in the chat pointed that out to me in a previous time, that the word myth has changed its meaning.
Well, to me, to say that something is a myth doesn't hit as hard as saying it's just a wrong idea. It's a false concept. It's a wrong belief. It's a false concept, or it's a wrong idea.
Yeah.
Or a false concept.
Yeah.
Calling those things myths, I think, basically takes away the impact of what your claim is. Your claim is that they're just plain wrong things that are being taught in physics.
Yeah, well, I think
But
that
calling them
brings
myths doesn't really have the impact of saying they're false. That's my opinion about it.
I think it's a problem, though, if you start saying certain things too strongly, people will start asking for proof. And really, I'm trying to put it the other way, that I want the main.
Well, a myth subjects you to the same counter. Well, yeah, prove that it's a myth, you know.
Well, that's what they could say. They could say prove that it's a myth, but
okay. My point is, I don't think that use the term myth is as hard hitting. You know, you want to say, when you're referring to something as being a myth, you want to say it's a false idea, or a false concept, or a false conclusion, or a false claim.
I think I was trying to explain what I meant by myth back at the beginning.
Well, I think I think that my point is,
why
are you using the word myth when what you really want to go after is to say that it's a wrong thing? It's false. It's wrong. It's not correct. Okay. Myth is too ambiguous. That's my point.
I was using it to mean metaphysical overreach.
Okay. Now, I don't know what that means.
Well, you got physics, and then on top of the physics, you've got the metaphysics. And so what you're doing is you've got an experiment, you've done the mathematics, and you've got the equations, and you say how you can interpret what that means. And that's the layer on top of it, which is the metaphysics.
I don't know what that means.
Metaphysics is beyond physics.
Well, what is metaphysical overreach? I don't know what that means.
When you're saying things which are beyond what the experiment actually shows.
Well, I don't really, give me some examples. I mean, to me, that's just that by what you're saying, metaphysical overreach is a wrong conclusion.
It can be a wrong conclusion. I mean, if you go into metaphysics,
instead of saying metaphysical overreach, why don't you just say false conclusion or wrong interpretation?
Well, when people start interpreting experiments, they come to lots of different interpretations. And so that leads them to build up lots of different theories.
Well, that's the issue with quantum mechanics. In quantum mechanics, they have all these different, what they call interpretations that go to the what's called the measurement problem. So you have different interpretations of the measurement problem.
That's right, yeah.
Okay. But the issue is which ones are right and which ones are wrong interpretations.
Metaphysics.
Okay. And they go and they claim, okay, so for instance, the Copenhagen people claim that this is the correct interpretation of what measurement means. And then this guy Everett had this many worlds interpretation. He has a different interpretation of what the experiment means. And people say, well, that doesn't make any sense to say that different universes are created when you make a measurement. And you would say that's metaphysical overreach. I would say that's just a wrong concept. Right?
But
it just looks to me like a wrong idea, a false
wrong concepts can be metaphysics.
Yeah, but I don't know why you need to call it metaphysical. It's
because it's
not
wrong. It's not based
just
upon
say
the
it's wrong. Let's just say it's wrong.
Well, in the case
it's wrong.
in the case you mentioned, you got the Copenhagen interpretation versus the Everett many worlds interpretation. So how would you determine that by experiment? And there's no way of doing that as far as I know. And so that makes it metaphysics.
I'm not sure that makes it metaphysics. It just makes it a difference of opinion.
Well, it's a difference of opinion. That is part of metaphysics.
So one group of people say, I believe that the Copenhagen interpretation is correct. Another guy says, I believe in the multiple worlds version is correct.
Yeah.
Okay.
Metaphysics.
So they can't both be correct, right? So
Well,
one of them's false and the other one's not false.
No. With
So one guy
physics,
says your interpretation is false and correct, and the other guy says, no, I think your interpretation is false and correct.
Yeah.
Okay, but they're not myths. They're not myths. They're just false ideas.
Yeah, the false ideas, that's part of metaphysics. No, the question is when you
I don't know
physics,
that false idea is a part of metaphysics. I don't know
what you say is your interpretation something we can prove by experiment? And if you can't do that, then it's metaphysics.
Yeah, but they claim that they are proved by experiments. That's the difficulty, you said.
Metaphysical overreach.
I don't know what that means.
That they're making a metaphysical claim which goes beyond what the experiment shows.
They claim that the experiment shows it.
Yep, and then which is a false claim.
I mean, they're claiming that everything that they say, the Copenhagen interpretation, the guy that says the multi-worlds interpretation, David Deutsch's, he claims, if you watch his videos, he says, oh, I've got this experiment and it proves that what I'm saying is correct.
Well,
so
I'm not aware of the experiment being done.
Overreach. They're producing an experiment that claims that supports what they say.
Yeah. Well, then that goes beyond metaphysics. Then it's back to physics when they do that. But until they've done the experiment,
it's just they're just making a claim that's either true or false.
Yeah, but physics can't always decide between what claims are true and what claims are false.
Well, this is an example of it.
Yeah. Well, there you go.
All right. Well, I think a lot of this terminology is confusing, and that's a large part of the issue about debate. You can take me off and put on somebody else. I've kind of made my point about that your terminology could be cleaned up a bit. And
I don't see how it can be. The words change.
I'm saying, what do you're using the term myth? That's to my idea, a myth, as Jim Keen pointed out, and you mentioned that, is a false belief. So why are we talking about myths when we really want to talk about something that's false? It's a false belief. It's a false concept, a false idea, a false conclusion.
On the physics side, you've got to prove that. And when you can't prove it, then it's beyond
you're waffling
physics.
Around. Okay.
If you can't prove it by experiment, then it's not physics. Okay. Thank you. Cheers. Thank you. Okay. Let me move. Cheers. Thank you. Right. So, anybody else want to go into the lion's den? Oh, we got loads of hands. Well, we got it. Well, I thought Vladimir was putting his hand up, but he's not. It's just Dennis. Okay. Hi, Dennis. Okay. Cheers.
Right. Yeah, I thought I'd comment on what Harry said and what you said. It used to be that science was about truth. There was no money in it, really. For example, Romer, the guy who set Newton up, with he lived in a house. He would climb up onto the roof, which was all sooty because they burned coal, and strap his telescope to the chimney and observe the moons of Jupiter. And when they were eclipsed, and he could tell a thing by the timing. But there was no one paid him a nickel. But nowadays, science has become not about truth, but it's the great adventure.
Yeah.
So, for example, there used to be a gravitational theorist by the name of Weber who had this aluminum cylinder antenna. It was supposed to pick up gravity waves, Einsteinian gravity waves.
Yeah.
And they finally found out that was an apparatus effect. But they didn't try to cover it up or talk about something else. they put his antenna in the Smithsonian Institute. Why? Because it was a great adventure. They had a great time.
Yeah.
You know, and this is getting worse and worse. The LIGO and the Virgo people
Yeah.
are they're mainly having a great ride because they detected gravitational waves, so they claim.
Yeah.
It's false claim, but they've detected gravitational waves, and there's so many people working with these organizations, and they're all getting promoted, getting raises in salary. Their papers are being published in good journals. And the fact that people like Richard David Scott, a former astronomer in Hawaii, they have a big telescope there on some high volcanic mountain. But he's retired now, and he's pointed out, he and another guy by the name of Michael something or other, I can't pronounce his last name, have shown conclusively, in my opinion, that the signals which are supposed to be coming from outside our galaxy and emerging neutron stars or some darn thing,
Yeah.
it's actually heavily correlated with the position of the sun and the moon in the sky, which controls the tides. The moon mainly controls it, but the sun also controls it to some extent. And the tidal forces on land and the tides on the ocean are, and so what they're apparently picking up is tidal forces. And because how could a signal from outside the galaxy be highly correlated with the position of the sun and the moon in the sky if it was really from outside the galaxy? Well, the answer is, of course, it wouldn't be correlated. So there's no question about what this
entanglement.
What?
The quantum entanglement.
What are you saying, Roger? I don't understand.
If it's entanglement, they've got this idea called entanglement. Maybe they could.
Yeah, I know entanglement, but
shoot all that into it.
But how does entanglement affect what I just said?
Well, entanglement is where you got two particles and they're somehow connected. And so
yeah, but so what?
Well, probably on the macroscopic level.
Oh, you think that the sun and the moon are entangled with the?
Yeah.
Oh my God.
You could probably speculate upon that sort of direction.
I don't know who could even believe something like that. I mean,
well, people have a go. I mean, they're into believing there's lots of different universes, multi-universe. So if they were prepared to believe that, then what else can they believe?
Yeah, I mean, you can believe anything because it's
it's
a great adventure and it's very well paid.
Yeah,
very well paid. And if you want to get promoted, and I went to graduate school at the University of California, Berkeley, and one of the scientists there was one of the three scientists who detected supposedly gravitational waves, and he got a third of the Nobel Prize. And so he's sitting pretty. He's got he's got his job at UC Berkeley, unless he's retired by now.
Yeah.
And he's got he's been promoted. He's gets his papers published, finest journals. And if it turns out it's all wrong, that's all right too, because it was a great adventure.
Yeah. I think a few Nobel Prizes have been awarded, and it's turned out later they were wrong anyway. So,
well, I don't know. I haven't heard of it.
I need to look into that. I need to see how many physics Nobel Prizes turned out to be wrong.
Well, and I've got one other comment, if you have a minute.
Okay.
A guy by the name of Desiderata, I think is his last name.
Yeah.
Is in the deconstruction of the English language, or was in case he's dead.
Yeah.
And, so that has led to things like you pointed out, that the word myth has changed its meaning. That
Yeah,
nowadays people are always changing the meaning of words. For example, racist. Nowadays, according to a lot of people, you can't be racist if you're not white. Only white people can be racist.
yeah. Positive discrimination.
Yeah, they're changing the whole language. So it's
Yeah,
like the Tower of Babel on in slow motion.
yeah,
The Tower of Babel resulted in all the different languages. That's the story of the
yeah,
Bible.
yeah. I
But,
know.
but that was instantaneous. Now they're changing the various languages, and especially in the Western world, so that you can't talk about certain things in an intelligible way anymore. You can't talk about racism anymore, meaning that
Yeah,
someone dislikes some other race, because if you're not white, you can't be a racist according to
yeah,
definition.
yeah,
And here again, this gets back to truth. They don't care about truth. They just want to get ahead with DEI and so on.
yeah.
Truth is not important anymore in this world, it seems.
Well, I take it all back to Einstein. Before Einstein, there was absolute space and time, space and time, space absolute, time absolute, and you had an absolute frame, and they sort of like got rid of all that. You get trying to get rid of absolute, so you had absolute truth as well, and then with Einstein, everything becomes relative. So then it becomes
Yes.
relative truth. So it's
Yeah,
all
I
Einstein.
enjoyed your talk today, by the way.
Sorry.
I enjoyed your talk today.
Hey, yeah.
Even better than the last one, which was good.
Okay. I was building on it. I was trying to show how the myths that are said about relativity lead on to the myths of quantum physics. So the whole structure of physics is based upon these
The whole
myths.
structure of the language, the English
Yeah.
language is being
Yeah.
changed.
Einstein's had a very
You can only talk in
Yeah.
terms of things that can't be true.
Einstein's had a very big influence by moving things from being absolute to making things relative, and it's been
Yeah,
adopted a lot.
he got the ball rolling, but I think
Mhm.
if Einstein hadn't come along, someone else would have. This Desirado guy, for example.
Well, if we cut Einstein out, what we had was Lorentz theory.
Yeah, in
throw away-
physics. But
You-
as far as redefining words in the English language, like racist, I think that would have happened anyway.
Yeah, well, Lorentz, if you're going from the physics, you get rid of Einstein, back to Lorentz theory, and you don't have all this relative stuff which Einstein introduced.
Yeah, it'd be nice if that could happen, but I don't see it happening. Do you?
Yeah, but so like people have been influenced by physics. They think physics is correct about things, and so it's then gone on to influence the rest of society. So Einstein's had a very big influence.
Yeah. Oh, yeah.
Relativism,
which is
Yeah.
the prevailing philosophy nowadays
Yeah.
in big academia, and they teach it
Yeah.
to all their students.
Yeah, but Einstein is the sort of like the big guru, whatever, that has influenced other people. The way physics is being done influences how other things are being done.
Yeah, the physicists have sort of taken over from in the days when the Western world was called Christendom.
Yeah,
The people that ruled were the theologians, but now
Yeah.
the theologians have been replaced by the physicists, theorists.
theorist.
Not
Yeah,
the people that built things, but the
Yeah.
theorists.
yeah. So it was science, wasn't it? Science replacing religion, but then science starts becoming sort of like religious as well, doesn't it? It takes on religious attributes. The atheist
they-
movement, yeah.
Yeah.
The atheist movement is sort of like they like to go by what they say is science, and they think anything about religion is false, but that they're then turning science into a type of religion.
Yeah.
So people are the same, aren't they? They want something to look up to.
Yes. Well, they'd like to. A lot of people have no idea what's true anymore,
Yeah. Well,
and
they get
that's
told by the
not
news media.
helping them.
Yeah. Yeah. So that's society now, all messed up.
Yeah,
It's
I
the
think
world.
I think it's
Yeah.
all a result of the fact that people nowadays want the good life, not they're not interested in the classical virtues like courage, or
Well,
fortitude, or patience, or what have you. They're interested in the good life
yeah.
and being comfortable,
Yeah.
very comfortable.
Is it the American dream to get lots of money and then you can live in a big mansion with a fortress and guards to defend you from the people outside?
Yeah,
Yeah.
that's right.
When
It's
you
not
realize
just
people.
in America. It's
Yeah.
I think the UK is going that way too. This new prime minister, Starmer,
Yeah.
he's
I think he's.
arresting people if they say the wrong thing on.
Oh yeah, yeah, that's right. Yeah, yeah, yeah. They cut down on certain freedoms of speech. Used to be freedom of speech, but then they decided certain words you can't use. You got to restrict
Starmer
certain.
believes that if there's a crime, you should always, a potential crime, maybe an alleged crime,
Yeah,
you should always believe the victim. You should never believe the person who's supposed to be the perpetrator.
yeah. Well, I'm a bit confused by what you just said. That it used to be that if a person says they were a victim of something, they got to prove it. Now, now it's swapped over to the other side. Is that what you said? I don't.
Yeah, now
Yeah,
you're supposed to
yeah,
believe the victim no matter what they
yeah.
suppose.
We got the classic case of Prince Andrew at the moment. Well, he used to be a prince, Andrew. Andrew, the news media have slagged him off, and they've already decided he's guilty in the public arena, and they haven't done anything through a court case yet. He's not been made a criminal from a court case. It's just the news media having made a judgment already that he's guilty.
Yes, yes.
So that's a mess up within society, isn't it? Total
Oh my
mess.
God. Yeah,
Things
if
have
the
flipped around the wrong
victim,
way. I don't.
if the supposed victim is
Yeah,
always right and the supposed perpetrator is always wrong,
yeah,
then anyone can play the victim and really get anyone
yeah,
else who they don't like. As
yeah.
claim they committed some crime and that's it. Off to the
Well,
prison.
I think the other way round was you could if you were clever, you could commit a crime, and the people that were the victims, they weren't able to prove it if you were clever enough. So it's a two-way thing. Can the victim prove it, or can the accused prove it? It's all mess.
That's the way it used to be, but now
Yeah,
things they're changing meaning of even of the words that you use.
yeah, exactly. Yeah, yeah, yeah. Have you heard of the? We're getting off tangent now completely from physics. Have you heard about this nurse Letby, who's been
No.
accused? She was found guilty of killing babies, and she's in jail, something like 20 years jail sentence, something terrible. And she's saying she's innocent, I think, but it was only just experts that were saying that she's guilty. Nobody's actually saw her kill any babies, so it's just expert opinion. And then we got come forward now experts who are contradicting the first lot of experts. So she's been convicted on one set of expert opinion, and she can't seem to get a retrial with experts saying the opposite. So it's a massive miscarriage of justice if she's innocent. And that's the world we
I don't
live
know
in.
where all this is going to lead, Roger.
That's the world we live in. If you're an expert on a certain subject, you can say, yeah, you're guilty, and they send you to jail. whether they've actually see you do a crime or not.
Yeah.
A terrible world, really. It's horrible if she's innocent.
Yeah, well, even worse if someone should watch this video and decide that you were guilty.
They could do, couldn't they? I mean,
Yeah.
the other thing they do is, oh, I can do something now, and it's not a crime. And then further on, say 10 years in the future, they can decide, oh, that's a crime. What you just did now is now a new crime. So then they backdate it and they look back 10 years at this video and say, oh, Roger's committed this crime. So I get persecuted for a crime which has happened and which has only just been invented in the future.
Yeah, that can happen too.
That's backdated. Pest. So I'm here trying to obey the law, but that's not good enough. I got to defend myself from laws that they can invent in the future. No, that's the world's crazy.
Yeah.
I obey the law. No, how can I obey laws that they haven't invented yet?
Yeah. Well, here in America, we have a no ex post facto law.
Which means, I don't know that. What's that mean?
It means that you can't pass a law, like you said, after you've done something to make it illegal and then arrest you. They can't do that here.
Can't they? In England, they can do. In France, they can. I think it used to be something like Napoleonic law.
Oh, God.
In Napoleon, it used to be a difference between France and England about the law. And in France, it was you've got to have a law telling you what you can do. So if you do something and there's no law saying you can do that, then you're breaking the law.
Oh, God.
But in England, it's the case of you can do anything you like as long as the law telling you there's not a law telling you you can't do it. So it was a reversal.
Yeah.
So, but so like we joined the European Union, and at one time, and then it's a mess of how we split off. So the law's kind of like messed up now. So you've had the difference between the English law and the French law and the way they do things, and that's totally messed up, and I'm completely confused. But it used to be called the Napoleonic law. You can only do things, you can only do something if the law says you can do it, which is the opposite of what we did.
Yeah.
So they can mess up the United States the same way further on down the line.
Yeah, I know.
The kind of everybody is the difference between people. Everybody doesn't do things the same way.
No.
It's all like I grew up thinking everybody must think about some of these fundamental things the same sort of way I do, and then you get bigger awareness of the world out there via the internet, and then it's like, no, everybody does things lots of weird ways.
Yeah.
We're all like aliens. Some aliens do things one way, and some aliens do things another way. We're the aliens.
Yeah.
It's not really clear who the aliens are. If some people had pointy ears, then you'd know, oh, those aliens, they're the ones that just like logic. And then you get some warning, but you don't get the warning. Everybody's got the same type of ears, so you can't tell one type of alien from another. They all look the same.
Yeah.
You don't get any warning. That's my view of the human race. They're full of, it's all a load of aliens, but they all look similar. You can't tell them apart.
Yeah, there's no way to tell.
No. So I'm talking to AI. I think AI is better than humans. It makes more sense to me than the human being. Do you know? I got AI, yeah, I can ask it questions and it responds in a more intelligent way than a human being would.
Yeah.
In my view. And so I'm finding out all these amazing things about myths and so forth in science, and sort of like the different ways people are thinking about things. So I find all this quite amazing. So what is the metaphysics? When I did physics, they never taught me anything about metaphysics. There's no no talking, no education for that. And so I found out about this metaphysics now. AI's introduced it to me, and I can read up about it. And this is one of the big problems of what physicists have. They're doing physics, and they don't know anything about metaphysics. You go off. They're sort of like they're metaphysically naive.
Yeah.
So they completely mess things up. They don't understand when they're talking myths. They
Well, they
think
don't really care. It's the great adventure now.
oh no, yeah, that's great adventure. They don't know.
Time
They're
and talking about interesting things and so
Yep.
on. And of course, the one thing they don't want is to have to pay for all these things.
Yeah.
Not the free money from the government or someone else.
Well, there's handouts, isn't it? You seen the cartoons of it?
No.
So like some people are old and frail and ill, and then you got lots of people pulling them along in a cart, and that's sort of like socialism. You're looking after people, and then further on down the line, 20 years so later, everybody's in the cart, and it's just one person pulling them along.
Yeah.
That's socialism. Everybody ends up as freeloaders.
That's right.
You kind of like, oh, it's a good idea to help the people who are in problems, but eventually everybody ends up wanting to be in the cart, claiming they got a problem, and it's only a few people left pulling the cart.
Yeah, Thomas Sowell, a black economist, he's in his 80s or 90s now, I think.
Yeah.
Was quoted the other day as saying that no society has ever prospered with a growing group of parasites.
Yeah.
In its society.
That's probably it. That's it. I think it was George Orwell that pointed out things like that as well in his stories. You know the famous one, the book 1984, George Orwell.
Yes.
He pointed out I think that the words changed their meanings over the years, and they keep rewriting history.
Yeah, that's right. He did. Huxley did too. I think.
Yeah. So he pointed out what was coming. It just to really to make this massive mess of society, you need computers.
Yeah.
So eventually the computers might take over. Next stage in the evolution is computers taking over, artificial intelligence.
I don't think so.
When I'm using artificial intelligence AI, it's sort of like, yeah, there's a danger that it's dumbing me down. Instead of thinking for myself, it's sort of like it's feeding me these answers for things to investigate.
Yeah, AI makes people who use it lazy.
Yeah. I mean, so when I had a calculator, all that skill in mathematics of being able to do the numbers in your head, I just forget that. You just do it on a calculator. So that was sort of like dumbing you down back then.
Yeah.
You don't do mental arithmetic anymore. You just do it on a calculator. So the machines take over and you end up being dumbed down by it all.
Yeah.
Just an ongoing process.
That's right.
Yeah, terrible. How's the human race going to survive? I don't know. What's the future got? They've already predicted it in these science fiction things.
Well, according to the Bible, what's coming is the Antichrist.
Yeah. Well, it's sort of like the on the Antichrist, it's sort of like you put the number across people's foreheads. But really, it's going to be a microchip they're going to shove into you, so you're permanently connected to a computer and the internet.
Yeah, that's right.
But that's the way it's coming. That's probably a reinterpretation of what the Bible really meant. That's going to be the beast. you shove your mic when you're fully connected to the beast via radio link. That's it. Wi-Fi. That's it. You are now a slave to Satan,
Yeah.
the AI. That could be it, couldn't it?
Yeah.
No? Yeah, you see it that way?
Yeah. It doesn't look good.
Doesn't look good. I don't know how anyway get out of it. Things is,
No, it's got to come according
yeah,
to prophetic literature. But it's
yeah,
only last three. Only reign worldwide 3.5 years.
yeah.
So
Okay, I think I've run out of time now.
yeah, I could probably have.
Yeah, it would be a good one to try to interpret modern science from the Bible. What's the Bible going to say about what's coming?
Yeah.
I don't see how we need some standards to progress in the future with science, and we haven't got any guidance. Okay. Thank you. Cheers. Thank you.
Yeah.
Well then, I'm closing down now. I think I've finished everything. Thank you, Dennis. Cheers.
You're welcome.
Bye. We move. Cheers. Bye then. Thank you, everybody. So, an interesting talk here on myths, and we've got lots of myths. And I don't know, how are you going to interpret myths? Are they truths or are they falsehoods? With the meaning of whatever myth meant is changed over the years. Generally, now we think of a myth as a falsehood, and science is full of myths. It's not just physics; it's all of science is now full of myths. And how do you cope with that? Don't know. But the next talk I hope to go into is how Einstein believed what Einstein believed, and they seem to be 4 fundamental things he believed in. I've used AI to try to reconstruct what Einstein believes, and it seems to be 4 fundamental things, and all 4 things are false. So yeah, science is now built upon 4 things that Einstein believed in, which all turn out to be false. So science is just building upon falsehoods. So hopefully I'll be able to do that next time. At the moment, it's just blowing me mind. So it's how to reconstruct what Einstein believed. And I think AI has been able to do that for me. So hopefully I will be back. Cheers. Bye then. Thank you. Ending